In this video, you will learn how to solve radical equations. Now, to solve a radical equation, we need to first understand a concept. And that concept is when you square a square root. For example, if you had the square root of 25 squared, what this means is that we take the square root of 25, which is 5, right? Because 5 squared is 25. So what I have is 5 squared, which is going to be 25. So notice what happened. This square and the square root basically just cancel each other out, and I'm left with just the 25. All right, let's take a look at another example. Let's say we had the square root of 36 squared. So the square root of 36 would be 6. So what I have is 6, and then that number is squared. So 6 squared is 36. And notice again that the square and the square root cancel each other out. So I'm left with just the 36 on the inside. So a square and a square root will undo each other. Just like addition and subtraction are inverses and they undo each other, or multiplication and division are inverses and undo each other. So also a square and a square root are inverse operations and will undo each other as well. So we want to be able to just get to the shortcut where we can just see that the square and the square root will undo each other. So instead of doing this middle step right here, we want to jump from the beginning over here to this end answer. So here we have the square root of 270 squared. Again, the square and the square root will undo each other. So what I'm left with is going to be 270. What if we had the square root of x squared? Well, again, the square and the square root undo each other, and I'm left with just the x on the inside. So my solution is x. Now, what if I had something more complicated, like 2x minus 3, take the square root of that, and then square that? Well, again, the square and the square root undo each other, so that'll cancel each other out, and I'm left with 2x minus 3 as my answer. Now, this concept will help us as we solve radical equations. Now, what is a radical equation? Well, it's not just an equation with the radical in it, but more specifically, the variable must be in the radical. So for example, the square root of x equals 4 is a radical equation because the variable is inside the radical. Whereas x times the square root of 5 equals 8 is not a radical equation because the variable is not in the radical. So our objective is to work with equations like this right here, the ones that are radical equations. So let's take a look at a few examples. Example 1, we have the square root of x equals 3. And our objective is to figure out what is x equal to. Now to do this, I want to get rid of the square root. Well, we've said that to solve an equation, we want to undo the things that we see written. So here we want to undo the square root. And to do that, I do the inverse of square root, which is going to be squaring. So what I do is I square both sides of the equation. When I do that, the square and the square root will undo each other. I'm left with an x on the left side, and then 3 squared, which is 9, on the right side. So my solution is x equals 9. Example 2. If I had the square root of x minus 3 equals 4, and I'm trying to solve this for x, what I need to do is begin by getting rid of the square root. So to do that, I have to undo it by squaring both sides. So I want to square both sides, and when I do that on the left side, the square and the square root undo each other, and now I'm left with x minus 3. So I have x minus 3 on the right side, or on the left side, and then 4 squared, which is 16 on the right side. Now the square root is gone, I can solve very quickly by adding 3 to both sides. Now I have x equals 19. Here is another example. Now we have the square root of 2x minus 1 equals 3. And again, I want to get rid of the square root. And to do that, I do the inverse of square root, which is squaring. So I'm going to square both sides. When I square the left side, the square and the square root undo each other, and I'm left with 2x minus 1. On the right side, I have 3 squared, which is 9. Now from here, the square root is gone, and now I can solve like a regular equation. So I work in reverse order of operations. I see we have 2 times x, which is multiplication, and I see minus 1, which is subtraction. So working in reverse, I start with subtraction. So I move that over by doing the opposite of subtracting, which is adding. So I add 1 to both sides. Now I have 2x equals 10. And then I can divide both sides by 2, and now I have x equals 5. So my solution is x equals 5. And by the way, for all of these, we can double check our answer by plugging this number back into the original equation. So if I put a 5 back in, I'm going to get 2 times 5 minus 1 equals 3. So the square root of 2 times 5 is 10. 10 minus 1 is 9. So I have the square root of 9 equals 3. Well, that is a true statement because the square root of 9 is 3. So I have 3 equals 3, which is correct. So I can confirm whether or not I have the correct solution by plugging the number back in to the original equation. Here is another example. So each example, we are increasing the difficulty a little bit. Now here, we have a square root, and we have a minus 3 over here. What I want to do first is make sure the square root is by itself before I square both sides. So like here, this minus 3, I want to bring it over to the right side by adding 3. That's going to give me the square root of 2x plus 1 equals 7. All right, now here at this point, once we have the square root isolated, now that it's by itself, I can now get rid of the square root by doing the inverse of square rooting, which is going to be squaring. So I square both sides. So when I square both sides, on the left side, the square and the square root undo each other, and I'm left with 2x plus 1. And the right side, I have 7 squared, which is 7 times 7, or 49. So now that I have the radical gone, I can solve by doing reverse order of operations. All right, so I see addition, and I see multiplication. So I do the addition first, and I move it over by subtracting. When I subtract, I now have 2x equals 49 minus 1 is 48. So 2x is 48, and from here I can divide both sides by 2, so x equals 24. So my solution is 24, and I can double check by plugging it back in. I'd have 2 times 24 plus 1, which is 49. So the square root of 49 is 7. 7 squared is 49. So 7 minus 3 is 4. That is true, so we have the correct answer. Example 5. I have negative 3 times the square root of x equals 12. Now I've mentioned in example 4 that before I get rid of the radical, I want to isolate it first, meaning get it totally by itself with nothing outside of it. So this negative 3 over here, I want to bring it over to the right side. And this negative 3 is being multiplied by the square root of x. So to bring it over, I do the inverse of multiplying, which is dividing. When I divide, I have the square root of x on the left side. 12 divided by negative 3 is negative 4 on the right side. So now at this point, I have the radical isolated, which means I can eliminate the radical by doing the inverse. So this says the square root of x equals negative 4. To do the opposite of square root, I have to square both sides. Now when I square the left side, the square and the square root undo each other, and I'm left with an x over here. On the right side, just be careful that you square the whole number of negative 4. All right, so you're not squaring just the 4, you're squaring the negative and the 4. So negative 4 squared is negative 4 times negative 4, which is a positive 16. So my solution is x equals 16. And I can double check by plugging it back into the original equation. So if I plug a 16 back in for x, I'd have the square root of 16 right there. The square root of 16 is 4. So I have negative 3 times positive 4. That's not equal to 12. That's going to be negative 12. So notice that when we plug this back in, it does not give me back out what I started with. So what that means is that this is not actually a solution. And that is why it's important to check your answer after you've solved. Because in some situations, as you see here, the answer we get is really not a solution. So this would actually have no solution. So that is my answer, and I can write that in math notation with a 0 and then a line through it. So either of these would be the way I can write no solution. So to recap everything that we have discussed in this video, when you're solving a radical equation, the first thing you want to do is isolate the radical term. So get the radical by itself on one side. Step 2 is eliminate the radical by doing the inverse. So instead of a square root, you would do the inverse, which is square both sides. So when you eliminate, make sure you square both sides. And then from there we can solve for x. So once you've solved, make sure you do double check your answer by plugging it back in to the original equation to make sure that your answer actually works. And that concludes our lesson for today. We will see you next time.